Dr. B.C. Roy Engineering College, myself, Dr. Soma Bishwas, one of the coordinator of the webinar, conveys warm welcome to all of you. It is our pleasure that we have assembled here on this virtual platform on the occasion of the webinar on modern trends of the electrical engineering and its applications. We feel very privileged to have amidst us our Honorable Director Sir, Professor Piyush Pal Roy, who is also former outstanding scientist of CSIR, CIMFR and Director CSIR, CMERI, Head of R&D Cell Professor C.K. Ghosh Sir, and our erudite speaker Dr. Nishant Kumar. Now I would like to request Dr. Sushanto Datto, Head of the Department of Electrical Engineering, to deliver the welcome address. Sir, please.
Thank you, ma'am. Good afternoon. Respected Honorable Director Sir, Dr. Piyush Pal Roy, Dean Academic, Dr. Chandan Chattaraj, Dean Students Welfare, Dr. Narendranath Pathak, Mr. Madam Roa Mitra, Head of R&D Cell, Dr. Chandan Ghosh, eminent speaker, Dr. Nishant Kumar, and distinguished participants. It is a moment of great pleasure, privilege, and honor for me to welcome you all to participate in the online and international webinar on modern trends of electrical engineering and its application. From 20th December to 24th December 2020, organized by Electrical Engineering Department of Dr. B.C. Roy Engineering College. In this webinar has 7 number of eminent speakers. They are coming from Jadavpur University, Calcutta University, NIT Durgapur, IIT Delhi, IIT Kharagpur, and National University of Singapore. Technology has made rapid advancement in recent time. The developments in the field of electrical engineering are also great. The whole electrical power system scenario has been transformed with advent of smart grids, interconnected grids, wireless transmission system, FACTS controllers, and renewable energy. The webinar are the needs of the hour under the prevailing COVID-19 environment. We can have discussions on emerging field in the technological recent. Participants will have an opportunity to share ideas with the speakers from different areas. I am sure that we all shall be enriched with new ideas and gather a lot of knowledge about recent developments in the field of electrical engineering. I hope you all will have a great time ahead. Thank you all. Thank you.
Thank you, sir. Now it is time for inauguration. Due to current crisis caused by COVID-19 pandemic, it is not possible to inaugurate this auspicious occasion with conventional lighting of the lamp. I request our Honorable Director Sir to inaugurate the webinar with his inaugural address. Director Sir, please. Sir, আপনার সাউন্ডটা মিউট হয়ে রয়েছে।
I think that everybody is getting my voice clearly.
Yes, sir.
Okay. Welcome to this international webinar, 5-day webinar, starting from today up till 24th December 2020 by the Electrical Engineering Department of Dr. B.C. Roy Engineering College. They have chosen the topic, Modern Trends of Electrical Engineering and this application. A very pertinent topic at this juncture. And I'm very happy that the faculties, Dr. Nishant Kumar from National University of Singapore, Professor Dr. Sumit K. Chattopadhyay, IIT Delhi, Professor Amitabh Chatterjee, Jadavpur University, Kaushik Sharma, Calcutta University, Corby Biswas, IIT Kharagpur, and Subrato Banerjee, NIT Durgapur, Professor Sapun Kumar Goswami, Jadavpur University, they will speak. They are all renowned speakers and renowned researchers as well as renowned academicians. So it's a well gathering, and they will be speaking basically on solar powered electric vehicle charging system, grid connected solar photovoltaic inverters, learning strategy for human robot collaboration and harmonious search algorithm and this application, as well as recent trends in automotive sensors and instrumentation and trends in electrical power systems. This will be the topic that will be covered within these 5 days. So it's a well gathering, and I think that this webinar will definitely focus on many of the new and emerging techniques. Now I am giving you some of the very pertinent picture which will enrich you further. You know that India's renewable power capacity has increased from 34 gigawatts to 82 gigawatts, recording 138% growth. And globally, India stands fifth in solar power, fourth in wind power, and fourth in total renewable power installed capacity. And if we consider the large hydroelectric projects, then India stands third in the renewable power capacity globally. So it's a very bright picture, I should say. At the same time, let me focus some of the truth picture of the Indian power generation system. When I visited actually in 2002 Bangladesh, I was very astonished to learn that they have only one power plant, which I visited, Barapukuria coal mining company, the nearby coal was being used for that one. Only 250 megawatt power, and that was with the help of Chinese. And they were mostly actually dependent on gas product actually. They have a huge number of gases. But in respect of that one, I am giving you the picture of Indian scenario. Our installed capacity, maybe more because I have collected this data 5 years back. Now it is 234,000 megawatt. It's a huge thing. And if we consider 80% of the production, then it comes around 162,366 megawatt, out of which 24% is hydro, 66.8% thermal, 7.6% gas biomass, 1.3% nuclear, and 0.3% oil. And overall, if you see the contribution of coal, it comes around 59%. So India is a huge country where so many applications you can find. So the alternate source of energy is very important in this aspect. Now, so far, this alternate source of energy, actually, I am giving you some of the pictures that our neighboring institute is doing, because I was in CMRA, so I know a little bit about the development. They have developed a green auto kinetic motors. I am giving this picture because you see that you also know that what has already been happened. They have developed a motor whose peak power is 5 kilowatts, and in normal range it is 3.5 kilowatts. It runs on three-phase induction motor, and maximum speed is 50 kilometers, and capacity is 5 passengers, and 100 kilometers per charge, actually, per charge. If you charge once the battery, it will run up to 100 kilometers, and the cost comes out 1.6 lakhs, and battery 6 volt 200 ampere 8-piece battery was connected in series. So this is the actually kinetic motors will come very soon actually. It was inaugurated in Delhi in 2016 during my presence as well. And the Solextra, the solar power based that our country developed, the same year I developed, it has the 240 watts actually, but China has come out. I heard that they have borrowed the technology from India, but before we could do it successfully, they made it with 650 watts. So this is actually if we develop something, the IPR, that is the intellectual property right, is very important. Otherwise, someone will take your invention to make use of it. So in India, we are doing very good in this respect. I'm talking about I do not know whether Professor Joyantopal is there or not, what is our solar energy installation. You must be knowing that we have also installed a 30 kilowatt peak, the solar power system in our BB building, where our Basic Science and Humanities department is there, and where we have installed 80 panels, and it is a monocrystal type of panels, and per day we have 120 units, kilowatts, and with an expenditure of nearly 13.5 lakhs. So we have installed this system, and with the invention that has already been made, and with the energy that we have, with the knowledge we have in our country itself, if we try, we can definitely, now our position is third position, we can definitely go to second or first position. It may not be possible because China stands fast. Huge amount of coal they are producing, and their whole system depends on coal production as well. Their coal production is something like 2.78 million tons, whereas our production is 650 to up to 700 million tons. Though we have a target capacity of 1,000 million ton is 2025. So China, we cannot beat China. That is true, because China has progressed much in respect of coal production, and the thermal power plant is running everywhere. But running a thermal power plant, there are some other issues which we have to consider. These issues, what are the issues? The issues are the environmental pollution. If you run a 1,000 megawatt power plant, there could be a chance of huge air pollution. I do not know whether you people have visited nearby Asansol and some areas. There are huge pollution was there. But in reference to that one, if you visit your Odisha, that is the Kanya as well as the Talcher power plant, 3,000 megawatt power plant is running, but you will not feel any pollution because they have controlled it in such a manner that there is absolutely no pollution is there. So pollution control is also a very big factor in power generation. So these are all the emerging areas. I would request the colleagues of my own college, the participants, those who are attending this one, they will be enriched with so much of solar power, electric vehicles, the grid connectivity, the learning strategies, then harmonious search algorithms, then automotive, then trains in electrical power systems. They will learn all these things, but they have to utilize their brain as well, so that they can also come out with some of the products, some of the protocols, some of the algorithms, which would definitely help to enhance our R&D culture. So this is very important, and I hope that Professor Sushanta Datta and whole team, Soma Biswas and their whole team, the way they have framed this one, it is really very appreciable. And at this juncture, actually, while all along this pandemic is going on, we are unable to meet each other. All the speakers are actually from different parts, but they have tried the level best so that something can be given, some inputs can be given, may be useful for the next generation as well. I also welcome our senior professors like Professor N.N. Pathak is there, Professor Chandan Chattaraj is there, Professor Chandan Ghosh, our R&D head is there. There may be many of the senior professors are also attending this one. And this is a very beautiful time, as well as it's a Sunday, but I think that they have actually chosen very pertinent topics. I could know that one of the speakers, Amitabh Chatterjee of Jadavpur University, will speak at 7 in the night, 7 p.m. His deliberation is at 7 p.m. So the way they have arranged it is really appreciable. I hope that this will be a very useful webinar, and something should come out of this one, which will be helpful to everybody, for the research, for the students, and all aspiring those who are working in a particular area. Thank you very much, and wish you all the best.
Thank you, sir. Thank you.
Thank you, sir. Thank you for your valuable suggestions.
I saw our registered madam also. She is
Yes,
also.
yes, we have registered madam with us. Sir, madam, welcome.
Thank you all. Okay. Thank you.
Thank you, sir.
Thank you.
Now, the first lecture will be delivered by Dr. Nishant Kumar. I would like to request Professor Kingsung Mojumdar joint coordinator of this webinar, to introduce the eminent speaker. Kingshu.
Hello, am I audible? Hello?
Yes.
Yeah. Today, our eminent speaker is Dr. Nishant Kumar. He is from National University of Singapore. He is going to give his elaborate and valuable talks on the topics of solar power electric vehicle charging scheme. So before come to the topics, let's introduce our eminent speaker, sir. Dr. Nishant Kumar is a postdoctoral research fellow in the Department of Electrical and Computer Engineering at National University of Singapore. There is area of research is your cybersecurity for smart grid and microgrid. He has completed his PhD from Indian Institute of Technology, Delhi, India, in the Department of Electrical Engineering, where he has worked on development of intelligence maximum power point tracking techniques and robust control algorithms for grid integrated solar PV energy conversion system. Those works have published in world's renowned journals such as 20 papers in IEEE Transaction, 6 papers in IET journals, as well as 5 Indian patents have filed. Moreover, his PhD thesis has awarded to the Best Thesis Award in 2020, first prize in IEEE IAS Industrial Application Society. Thesis contained in your 2020 PhD category. Moreover, his PhD thesis has also awarded to the Best Thesis Award 2019 in Indian Institute of Technology, Delhi, as well as he has received POSCO Power System Indian National Award in doctoral category. He has completed his MTech from National Institute of Technology, Durgapur, India, where the university has awarded his research work to the gold medal. In between his MTech and PhD degree, he has worked as a project engineer and research associate at IIT Bombay and IIT Delhi. He had completed the bachelor degree BTech from Silicon Institute of Technology, Bhubaneswar, India, where he had awarded to the Best Technical Students Award. Recently, he has facilitated by IEEE to the IEEE senior members and by the DST Government of India to Young Scientist Award to represent India in 5th Bharat 2020 Young Scientist Clever, which held in Russia. He has more than 50 publications, including international collaborations such as Imperial College of London and other colleges in UK. This is a brief about Dr. Nishant. I would like to ask Nishant sir kindly give us your idea regarding today's topic, sir. Please, sir.
Thank you, Kingshu. Thank you for this brief presentations and discussions about me. And now I'm sharing my screen, then I'm going to start.
Sure, sir.
I hope my screen is visible to everyone.
Yes, sir. Is it
Yes,
visible?
sir.
It is visible.
Okay. Hello, everyone. First of all, I like to thank BCRO Engineering College, Director Sir and Registrar Madam, as well as whole electrical department and organizing committee for organize this beautiful webinar session. In this webinar sessions, I'm welcoming you all. Today in this webinar session, so many good things has already started. For example, Director Sir has started and pointed so many good things, especially for the environmental control. And I am also happy for that because I have also visited those plants what sir has discussed. And also in Odisha also, Talcher and all, I have also visited. And in Talcher area, is definitely, I agree with that, the climate change, or we can say the climate, pollutions are very controlled due to the properly manage the plants, and especially for that. And as well as also, I'm very very happy for this session, because my MTech is from NIT Durgapur, and for me, the Durgapur is like a home ground, you can say, because I have done my BTech from the Odisha, but my MTech is from Durgapur, and especially research I started from the Durgapur, and so this is for me this is a very great opportunity to present here. So today I will discuss mainly about the solar powered electric vehicle system. This is a very upcoming area, as well as few companies already working, but still few challenges is raised here, and so many people have tried to overcome those problems. So mainly I will focus on those problems. Where is the problem and what is the issues with solar powered electric vehicle? But before going to start, I want to share that this is not a hypothetical things. This is already existing. Already one Dutch company is making this solar powered electric vehicle, whose picture is on the screen. You can see those pictures. That this car is already running in Germany. The one Dutch company, Lightyear, is making this car, and so many other examples are also available in our society. I will also show those photos, and then I will go for the control and what are the issues behind that. I will try to point out that. My bio sketch almost Kingsu has discussed. Kingsu, I am talking about again and again Kingsu because he was my classmate. So directly I am taking his name. So please don't mind. My bio sketch already he has discussed in detail. So no need of that. Directly coming on the point, the electric vehicles. Now, in everywhere we are talking and discussing about the electric vehicles, but I am starting from the basics. What is the electric vehicles? The one line discussions and one line definition of the electric vehicle is that when we are replacing combustion engine to the electric motors, that will be the electric vehicle. That motor will run through the electric power from battery, hydro energy, fuel cell, and grid power, whatever. That is not the matter. Matter is that the combustion engine, where we are burning our fossil fuel, that engine will replace to the electric motor. That is our electric vehicles. But the question is why we are thinking about these electric vehicles? Because in electric vehicle, again, we are thinking about the electricity, and this electricity again comes from coal, or we can say the oil also, because so many countries, for example, in Singapore, here gas plants mainly has installed for the electricity. So many countries, so many different types of fuels have used for the electricity generation. But still, we all are talking about the electric vehicles. The main reason is that the charges. Charges means the cost per kilometer. For in India, this what I have shown here. This is for Indian climate or Indian circumstances. You can say I have considered all the price according to the capital city Delhi. So on that price, you can see if you are using petrol for car, then this cost is around 5 rupees per kilometer. Similarly, in diesel and CNG, 4 and 2 rupees per kilometer. But if you are thinking about electric vehicles, then that is 0.75, means 75 paisa per kilometer. This 75 paisa is for what? For 6 rupees per unit electricity. And this electricity currently coming from the coal plant, nuclear plants, and some renewables also. So this price is very high. Think once when the renewable will on the maturity level, then definitely this price will go down. Means not 6 rupees, it will go down. When this per unit charges will go down, when more and more renewable will penetrate in our society, that time this price will be definitely lower than that, and that time this price will per kilometer charges will again go down. So this is extremely cheaper. That's why nowadays everyone is thinking about that. You can say climate change, pollution, and whatever, but for normal public who is going to buy, they are not, mainly in India, they are not thinking for these things. these are the byproduct of that. But the prime thing is price and money. This is cheaper, so people are thinking. Also, the another thing, why into 2020 we are thinking for that, and to 2030 we are it will be on the extreme. Everyone is forecasting, and everyone is planning to this electric vehicle will be on the extreme in during the 2030 and 2050. It will be the single option in our society. The reason behind is this gap between the oil demand and oil generation, means how much oil we are producing and what is the total demand. This oil demand is increasing day by day due to the two things. One is population, and population using the vehicles, different type of transport system, and other things. So due to that, this oil demand is increasing day by day. So this gap is increasing. When this gap is increasing, then price of the oil is increasing. When oil price is increasing, then we know that directly it will impact on our whole product. That product is our food items or anything. This will directly impact on that. So this gap, oil production and oil demand is increasing day by day. So these things this is the time where everyone had to think about this. What is the alternative with us? So you can see. So now everyone is talking about the renewable as well as the electric vehicle. This too is the key part of our society, and we can say the key area of research, because this too is the most upcoming area in electricity or electrical engineering, we can say. Definitely the byproduct, the population will be controlled, the pollution will be under control, because the CO2 emission is also increasing. When we will use more and more renewables and more electric vehicle support, then definitely it will be under control. So this is also
Hello, Nishant sir.
Yeah.
Sir, yes, sir, myself, Kingshu. Sir, kindly hide the tag, sir. That GME tag, lower the axis, the x-axis, on the graph of the x-axis, sir. Yeah, sir, hide it. Sir,
Okay.
only click on the hide. Hide is written there.
Yeah, I've seen. I can see.
Yes, sir.
Now it's okay.
Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you. Due to the CO2 emissions, definitely the climate change is also happening, and the environmental temperature. This is not environmental temperature. This is the ground temperature is increasing with our carbon emission. So this is also one key area which we can control only by using the more and more electric vehicle and renewables in our society. So overall, we can say, so due to these things, the price and the pollution and all the climate change, the renewable is the key demand in our society. But in other way also we can think. So suppose someone is telling, okay, few developed country directly generating electricity by using the oil, or you can say the few Arabian country also generating electricity by using the oil. So why they will think about the electric vehicle? So this is the answer of that. When we are producing oil from a well and using and transmitting that oil and burning in our combustion engine, and vehicle is running, so what is the efficiency? Efficiency here, well to wheel efficiency, that is around 13%. But the same oil, when we will take from the well and generate the electricity by using the oil-based generation plant, and then that electricity we will use in our vehicle, and then this efficiency will be much higher than this. Here both side we have assumed same oil. I'm not talking about the solar, or we are not talking about the coal and hydro. In the same oil, also this electricity or this electric vehicle type of arrangement is much efficient with respect to the existing our infrastructure. So that's why the Arabian country is also taking interest in this area. In Dubai also, the electric vehicles are nowadays much popular. That's why Tesla is continuously pushing new type of electric vehicle in Dubai and Kuwait and all like this. What are the types of these electric vehicles? The one is the most conventional type, The conventional type is means that we will use the fuel and then we will burn inside the engine and then we will run our vehicles. This fuel is not fossil fuel. This is hydrogen fuel. Means here fuel cell have used. If we can use the hydrogen here, and that hydrogen will use in fuel cell, and then fuel cell will generate the electricity for engine, or we can say for motor. So this is one way is that. Another way is that we will put one battery, and means hybrid one. We will put one battery, and this battery will charge through electricity, and that electricity will come directly from the grid. We are not talking about the grid generation. The grid side generation may be coal and hydro and whatever, but directly we will store that energy in battery, and we will try to run our motor by using that battery. But in some cases, when the battery energy is not available that much for according to our requirement or according to our circumstances, that time this fuel will burn, means hydrogen will burn in fuel cell, and then again our engine will run by using those electricity. So this is the hybrid one, and then final one is only battery will be here, and this battery will supply the power to the motor, and then motor will run accordingly. But here how we will charge this battery. We have two options. One option is that we will take electricity from grid and we will charge the battery. Another one is that we can put one solar panel also on the rooftop of this vehicle, and then we will charge this battery and we will run our motor. So this both options we have in pure electric vehicle. Here the benefit is that with respect to the fuel cell, when you will think about the fuel cell, this hydrogen, we are using the hydrogen and generating the electricity. It looks better, it looks very simpler, but here the hydrogen generation, because here hydrogen is the fuel, hydrogen generation is a costly task. So this technology had not become much mature. Definitely, in single word, you can say I will break the water particles, water molecules, and generate the hydrogen from there. But during break of this water atoms, again required some electricity for anode and cathode, so that the water molecules will break and you will collect the hydrogen and store in a tank. So this is again the one costly task. So still researchers are working on that. So how we can minimize the cost and reduce the hydrogen energy generation. So that is another way. But the most simpler what we have, that is the solar side. Means we can use the solar for the power generations, which generated power we can use in battery and run our motor. Definitely, in some cases, in certain circumstances, solar will not capable. That time we will use the conventional grid for charge our battery and we will run our electric vehicles. Means this type of combination we can use in our society, which will most reliable and most efficient with respect to all other available type of combinations in electric vehicles. Here also again I have shown the all different type of arrangement. The first one is the fuel cell based, means directly the hydrogen tank we have used as a fuel, and this hydrogen tank supplies the hydrogen to the fuel cell, and this fuel cell generates the electricity for motors. This is the one way. Another way is directly conventional one, means directly we are using the battery and this battery is charging from the grid. No other generation system is here. That directly we will charge from grid and run our motor. This is the most simpler one. This is a one way. And the third one is we will use the solar panel on the rooftop of the vehicles, and this panel will generate the electricity, and that electricity will use for battery charging as well as motor run our motors like that. And definitely this power generation and the load demand will mismatch. That time battery will support, and when this battery power will again go down, then we can use this connection, means the grid, for charge our battery and run our system. So this one is in between all the three. This one is the more reliable one. Definitely it will little bit costly with respect to this vehicle, because here no any solar panel has used. So this vehicle will little bit costly, but the payback period of this vehicle will around 2 to 3 years only. when we will use this type of combinations, and then this will, after that, the whole we can think about the long time cost. Then that definitely it will be much beneficial with respect to this. So these are the arrangement. This is the electric vehicle, solar powered electric vehicle, which are available in market. This light year company, Dutch company, is making this, and high efficient solar powered seat has used on the rooftop of this vehicle. In general, in our market, what the solar panel is available, the solar panel efficiency is around 20 or maximum 22% nowadays, which what we are using in our society. But this is most efficient solar panel has used. Here the efficiency is around 27 and 28% is the efficiency of this seat. And this seat arrangement is also very good. It is very flexible in size and shape, so that it has arranged on the rooftop according to the wheel's aerodynamics structure. So this is the very good thing with these seats. Also, the same concept already have used in Australia. Australia is running 100% powered electric train in Australia. This is already running. This concept is already proved there. Similarly, so many other car companies are also working on that and making. So the Suzuki and Toyota also, they are making this type of vehicles, solar powered vehicles. And this bus is already running in China as well as Germany for public transport. So these things are not totally new, and these things are already running in our society. But what is inside this system? In simpler form, we can say this arrangement is just a boost converter. We can say just a DC-DC converter is inside this system. Means one side, the one node of that system, this control is attached with the panel, and this is input side, and outer side is the one DC output, which is on the DC link, and this will attach with a DC motor. If inside the car, we are using the DC motor. So because electric vehicle also can run by using the DC motor, this is also one solution. So this one is the most simpler one. But definitely this is simpler one. But in practical, this will not inside that. In practical situation, inside the controller will be looks like this. When you will think about the complete system, the system will look like this. Means here, definitely on the rooftop, solar panel will be, and this solar panel will attach with one DC-DC converter. This DC-DC converter is used for maximum power extraction. Means this DC-DC power will force the solar panel to run on a maximum power point. So this DC-DC converter is used for that. And this DC-DC converter is operating by using this MPPT controller. This MPPT controller decides the operating point, and according to that, this DC-DC converter operates and run the system accordingly. Another one is here, this AC to DC converter. This is for backup. Means when this system will not capable, then we will use the grid, means the charging infrastructure, direct AC power, and this AC power will convert into the DC for the battery charging as well as our load also. But definitely during the running time, this will not use here, because this charging system will work during the on a charging station. So this will use for the battery charging and like that. And this charging is called the onboard charging infrastructure. As well as also we will use here battery. This battery will supports our motor during the power fluctuation as well as backup also. So this battery is connected with the bidirectional DC-DC converter, means for charging as well as discharging. In both situations we can use this battery. And according to the condition, according to the secondary controller, this is the prime controller. Prime controller is only for the MPPT, but the secondary controller will manage all the power generations and power transmission. So the secondary controller will decide the operation of this DC-DC converter. And this bidirectional DC-DC converter will run behaves like a source and sink in both situations. And this is our motor. According to the motor, this connection will be here. Suppose we have used the AC motor or induction motor, then this is DC to AC converter. But suppose this is DC motor, then no need of this converter. Directly we can attach to the DC link like that. So this is the simple control or simple arrangement of the solar powered electric vehicle. Here, the secondary control will manage all the power generation and power fluctuation. The objective of the secondary controller will see the see the power variations or see the this DC link voltage or DC link power, and accordingly take the action. Means here the power is more. That time it will use for the charging. When it will low, then it will discharge and manage the power on the DC link, power as well as voltage on this DC link. Similarly, the solar powered side, this MPPT will run. This is the primary control, and this will not efficient. And here power is not coming on this node. Then definitely it will go for the charger and charging infrastructure for charge this vehicle. So this is the most simpler control structure inside the solar powered electric vehicle. But the question is, when this sun will directly interact with the solar panel, then only this panel characteristics will be look like this, because we know that the solar panel characteristics is like this. It is just like an inverse parabola. What is the meaning of this? This inverse parabola means on x-axis is the voltage and y-axis is the power. According to the voltage, according to the operating voltage, it generates the power. This is the one issue with this panel. It means it will operate on the lower voltage and power will be low. And when this will be high, then also low. So need one optimal positions or optimal operating voltage, so that we can get the maximum power from this panel. So for that purpose, in general, we use the MPPT. But this characteristics is only when sun will directly interact with the panel. But in practical situation, the situation will like that. Means in our city, the car will run here and there. So when car will run here and there, then we cannot say sun will directly interact with the panel. Definitely the shadow will fall. The shadow will fall on the panel. Since when shadow will fall on the panel, then the characteristic will not look like this simpler one, because this car is moving in our society or city like this. For example, few figures I have shown here. When directly sun is interacting with the panel, then characteristics will look like this. But whenever any obstacle will come in between the sun and the vehicle, then shadow will fall on the vehicles, or shadow will fall on the rooftop solar panel. Then characteristics will be look like this. Similarly, suppose tall buildings are there, then due to that building also, shadow will fall on the panel or vehicle. And that condition, in that situation also, the characteristics will be look like this. And in this type of complicated situation, a normal MPPT technique will not work. And another thing is here, this shadow is also not a fixed shadow, because vehicle is running. Vehicle is running means the shadow area covered due to this obstacle or area captured by this shadow will also change. When this shadow will change, shadow pattern will change, this characteristics will also change. The change pattern and speed of this characteristic change will depend on the speed of the vehicles. If vehicles are running very fast, then this characteristics will be changed accordingly. So here, how we will operate our system, this is the main thing. Before today, we all discussed about the solar panel. Solar panel is a static thing, which will be on the rooftop or which will be in a park. But here, this panel is running, moving with a particular speed. So in these situations, this is a very complex thing, how we will decide the operating voltage. In this situation, again, the x-axis is voltage and y-axis is power. You can see the different voltages will generate the different power. If you will not select the proper voltage, then power will be not optimal. And already you know that the panel efficiency is very less. In general, it is 20% or 22%. So we are trying to optimize this whole operation so that we can choose this operating voltage as early as possible, so that the system run on efficient manner. So also you can see the characteristics. When any obstacle will come on the panel, then it will look like this. Multiple peaks will come, and this characteristics behaviors will be very dynamic, and this continuously it will change when if vehicle is running. And this situation is not only on the vehicle side, also on the our society also. During the snowfall, in the snowfall area, you can see when snowfall falls on our panels, then this type of conditions happens. And here again, this is also one example of partial shading. Similarly, in the desert area, during the due to heavy dust, all panel faces this the same issues what I have discussed previously. Means this is partial setting. This means multiple pits will be in the characteristics, and normal MPPT technique will not work here. And this is not only on the Earth, also on the Mars. You can see this news. NASA has reported this issue on the Mars rover. Due to heavy dust, this rover is facing this partial setting conditions of the rover panel, and then again here also required one maximum power point tracking technique which is dedicated for the partial setting. And so for that purpose we have to think about this, so how we can track. So when I started my research, that time I have gone through so many literatures and so many available solutions. So many people have worked on that, but those solutions are only for the static panels. Means the shadow due to the snow, shadow due to the dust. So on that moment you have enough time to search and operate accordingly. But here vehicles is running, and when vehicles is running, then we have not that much time to search, and we here required a very fast and accurate searching algorithm. And this is not offline searching. Means that what algorithms we are using in power system side or planning type of problems, that searching is offline searching. Means you have not that much time bounded, but this is totally based on the time bound. So for example, one situation I have shown here. On the y-axis, in z-axis, you can see the time. Time is in between 0 to 1. According to NERL report, NERL is a lab in USA. According to that, the considerable solar radiation change happens in 1 second. Means we have to finish our searching within a second, because this searching algorithm directly use on power converter, and that converters are running on kilohertz. So here, what searching algorithm we are going to use, that searching have to finish within a second. Means we have 1 second to finish our search, and that searching output of that search will use on our converter to operate on that. So you can see this figure also. This 3D figure shows that on the z-axis I have shown the time. Time is in between 0 to 1, or means 1 second. After 1 second, you can see different type of characteristics are appearing, and in each curve you can see LMP and GMPP. LMPP means local maximum power point, and GMPP means global maximum power point. So, and here also I have shown the voltage. So you can see this is our output results. Means what algorithm we are going to use, that algorithm will decide this voltage, and according to this voltage we will get this power. If this voltage selections is not accurate, then this power we will suffer, we will lose some power. So for example, so you can see here, suppose this operating voltage is 100, means power will be here. But on the same time, if our algorithm has given the right answer for 220 or 230, whatever, so this is the power. So that is the maximum power. So here required a very fast, accurate, and online searching. This is the very crucial here. Similarly, one other examples I've shown here. So with time, how the patterns are varying, and here again the time is 1 second, and patterns are continuously changing after again one after one, just after the 1 second. So when you will think about this objective functions of this optimization problem, objective function is very simple. Maximize the power. The target is very simple. Maximum PV power. So I can write like this: max PPV. And this PPV will decide to the voltage, and that voltage is controlled by DC-DC converter, and this DC-DC converter runs according to the duty cycle. So we can say this power is the function of duty cycle. Means what duty cycle we will set, so the converter will run according to that voltage, and that voltage will reflect in the terms of power. So we can say this is the maximum power, but this power is the function of duty cycle. But this power is DC power, so definitely this power means voltage into current. This is PV voltage and PV current, and multiplication of both is the power. And this is the constants, we can say. This is the objective this is the variable also. We can say this is the variable duty cycle, and this the constant of DC converter is in between 0 to 1, because we know that the duty cycle will be always in between 0 to 1. So in problem side, the problem formulation is very easier one, very simple one. It's just we are optimizing the whole system for a particular duty cycle. So is that when I started my research, that time so many people have published so many papers, means few papers, few algorithms and few techniques I have noted here. But when I gone for the all NERL report and conditions of 2018, this has decided so considerable solar radiation change in 1 second. And on this parameter, that time in 2018, only one algorithm was capable to track the whole system within a second. The name was that flower population optimization algorithm. According to literature in 2018, this was the single paper which was capable to track within a second, and the time taken was 0.85 second. 0.85 second means what? Means 85% time this algorithm is investing for searching, and rest 15% time on the full strength, because after 1 second the system characteristics will change and the problem will change, so researching is required there. So on that basis we are concluding, so these populations invest 85% time for searching and only 15% time for the full strength. So how we can reduce this time? This was the key challenge. So for that purpose, I have developed a new algorithm. Sorry, here title is not showing, but the name of this this algorithm is HPO, means Human Psychology Optimization Technique. This is the name of this technique. I have developed this technique. This technique is totally based on the mental and psychological status of any ambitious persons. Means that this a new meta-heuristic optimization technique I have developed here, and this optimization technique is mainly based on the 4 positive energy, and that positive energy is excitement, self-motivation, inspiration, elation. Means that this 4 energy psychological energy I have used here for problem formulations, and that formulated all the equations have used for the searching. So before going in the details of this, so we will try to understand why this 4 factor is important, because any ambitious persons, before going to take any physical actions, they decides the physical action only on the 4 parameters. The name of these parameters is excitement. Excitement is a random energy which it does not depends on anything. It only depends on our self behavior, or also we can say our society or our personal nature. This is totally a random behavior. But another is self motivation. Self motivation comes from our past experiences. What are the qualities we have, what are the expertise we have. On that basis, this self motivations triggers. And the third one is inspirations. Inspirations, definitely it is the influence energy which comes from the other persons who have on that area. Other one is the decision is also is that what are the on that same area, the fields, what the mistakes have done from this lessons comes. So after accounting all these 4 energy, this person takes final decision. So this energy, the mental energy be based on this 4 factor. And after putting the 4 factor, that energy over again cross checks by overexcitement and depression. Maybe the energy level is very high, so that is overexcitement. That is also not good for the system. So that time when our energy level will beyond that threshold value, that time any mentor or external guide will picture, and they will suppress our energy to work in a proper zone. Similarly, the depression, maybe the overall energy level is very low. So that time again, the external mentor and external guide will come in picture and push our energy or encourage and improve our energy to work or perform in a real ground. So this what I have decided, what I have done. So also one example is shown here. For example, in these examples, this young boy want to be a good athletics. Before going to take, say training, what are the things will come in his mind? The two things. One is excitement. Why he's thinking like that? Because he is young, slim, he has a good health, so he can think, okay, this is excitement. He is excited for that. Yeah, he can do. But also one self motivation. He want to be a good athletics on the national level, but this self motivation is coming from his past experiences. That experience is not on the national level, but in his school time or anywhere. If he has done anything related to this area, that will give little bit confidence. Okay, I can do. So this is called the self motivation. The third one is inspiration. In this in this athletics area, who have performed better. So from there, some inspirations or some positive energy will come. And the third one is lessons. What are the failures have done? What are the mistakes they have done? So this will again give some idea about that. So what are the wrong thing that we don't have to do? So this four factor finally decides the final package of energy for taking the final. This is totally based on that. Also, again, in this picture, on the I show the mathematical derivation of all energy level, but here in the pictorial form I have shown during the searching how the particles move. Here I have shown for the particle C. The particle C, again, it will be the four factors. Pink color, this is the random one, and then both green is for the inspiration, and this yellow one is due to the self motivation, and then the last three blue is due to the lessons, because here is the target. So these are the failures. So this will give some lessons, and they are performing better with respect to the C current positions, so they will inspire. So this green light is a green energy level, or we can say green vector is coming from there. And then finally, after all, including all vectors, then red one is the final strategy. So this type of thing will happen for all particles, and in each iteration, all will iterate accordingly. Here I've shown the mathematical formulation of that. The first one is excitement. Excitement is a random behavior. So this excitement is always decaying in nature. This is exponentially decaying in nature. So means that with time, whatever work we are doing, if the same work we will do again and again, then definitely this excitement will go down, because when maturity increases, excitement goes down. Similar thing happens in our life also. With time, with age, our excitement goes down, but our confidence or maturity increases, but excitement decreases. So this is according to that. So here iteration number will increase, and this will go down. And also, this is not a bad thing. This is a good thing, because excitement gives the positive, heavy positive energy for experience or for learn. But when we have learned a lot of things, we have to settle, or we have to the work according to that. Means that with our confidence or with our safety. So these are the things. The second one is motivation factor. Self motivation factor directly based on our previous performance. What are my previous performance? According to that performance, this self motivation factor will generate, and this factor will be based on our spirit factor, and this will be based on our enthusiasm factor. Similarly, the third one is inspiration factor. Again, this inspiration factor comes from all the good performers or best performers. So what are the other particles or other searching agents are performing? According to that, this inspiration energy will generate. It will based on what? The influence factor. This is influenced energy. So this is influence factor. So similarly, the third one is lesson. Fourth one is the lesson factor. This lesson factor, directly a negative energy comes from all the failures, and that failures gives this consistence factor, and this will based on the fear factor. So like this, all the four factors mathematically I have derived. So so by using these all four factors, the whole system iterates in each iteration. Similarly, for different populations, the few examples I have shown here. For example, so you can see here, Here A is performing very good. So you can say, see, the influence factor for A is 0 because no one is influencing because he is on the top. But see, downside, he is performing very poor. So here all the other particles are generating some energy for him. Means all are giving some inspirational energy, inspirational positive energy. So this particle can take a bounce back or can take a big jump in each iteration. So due to this, the searching or iteration performance has increased significantly due to this energy. So how the lower one is also influencing to all and performing better. Similarly for the others also. For example, suppose I'm thinking about H. For H, these are the good performers. So they all will inspire and they all will pass some small amount of energy, and he will get all those energy for perform better in the next iteration. Similar like that. Though finally, all the factors I have included here and have shown here. These final equations will look like this. In this final equation, this is the duty cycle for the next iteration. This is the duty cycle for the previous iteration. But here in these four factors, lambda 1 is the random number, and lambda 2 is the second random number. Two random number has used. This mu is the excitement factor. This S is the self-motivation, N is the inspiration, and L is the relation factor. This relation factor is a negative energy. Also in the vectorial form, I have shown here. So you can see the excitement, self-motivation, this is 1 and 1, but here so many inspiration factor will be here, and this so many relation factor will be here, but this is a negative one. So finally, this will look like that, and due to this, all the four, the next iteration or next updation will happen. But again, in this whole system, you will see the four type of algorithm parameters have used, but all parameters are interlinked with each other. So finally, all four parameters, algorithm parameters, are interlinked with each other, and then totally based on one. That is the omega. Means in the whole system, only one algorithm parameter is omega. We have to tune this one, omega, and omega value is 0.1 and 1. Like this means this value will be always in between 0.1 and 1, like that. Again, I will show. So if we will not select properly, then what will happen? I will show. Similarly, in the next iteration, overexcitement will happen. Means you will check the energy level. This is above the threshold value or below the threshold value, and then we will, according to that, suppose this is overexcitement, then we will suppress, or means we will reduce some energy for coming active region. Similarly, depression situation, we will add some extra energy to push in active region, and like that. Similarly, one new thing is here. In each iteration, according to the performance, all populations will scattered in three parts. First, not three parts, or three groups we can say. The first group is the good performer. The second one is the average performer, and the last group is the red one, is the poor performer. And in this algorithm, in next iteration, this poor performer will not go. Here only two groups will participate in next iteration, the good performer and average performer. But on the place of poor performer, a new set of population will generate by using the crossover and mutation process, and that new generated populations will replace the poor performers. Populations will play the role on the place of poor performance. So these are the two equations. Heuristic crossover process and heuristic mutation process will be used during the generation of new 1/3 of populations. Also, you can see in the pictorial format here. So in this picture, you can say this is the global best performer, or we can say the topper. This is the topmost positions holders will be here, and rest all green is the member of the good performers. In this group, all will interlink with this, and they will generate the new chromosomes. This is the chromosomes. This generated new chromosome will replace the poor performance. During this generation, two factor, mutation and crossover. Means this direct line is mutation, and this dot line is crossover. Means this is mutation and this is crossover. Through that, this energy will generate, and like this will happen. This is the flow chart, and this flow chart is very simple. It's looking maybe complicated, but this is very simpler one. Means each time we will pass all the particles to run the algorithm, and according to the performance, we will give the rank, and according to rank, we will update all the particles, and after that, poor performer 1/3 will replace to the new populations according to the rule and by using the mutation and crossover frequency performance like that. But what algorithm I have developed, that algorithm I have not used directly on the converter. So first of all, I have tested this algorithm on the benchmark functions. Here for testing, I have used the unimodal benchmark function. Similarly, multimodal benchmark function and fixed dimension multimodal benchmark functions I have used here for testing or validating this algorithm, what algorithm I have developed, that is really or actually performing better, or this is my thought, or this is only hypothetical. So for that purpose, I have used a total 23 benchmark functions. These are the mathematical benchmark functions, predefined benchmark functions, which I have used here for testing. During this searching and during these performance evaluations, I have used the 3 other techniques for finalizing, means Gray Wolf, PSO, and DE. 3 most popular techniques I have used for comparative study, and here on that basis I have seen that so HPO is performing definitely better, but not in each case HPO is better, but some cases it will you can see this is very similar to the previous one. Means like this, here is also the best performance result is 0, but as here also this is 0, because this all the problems are based on the minimization. So here both are able to detect the final best result. But in worst conditions also you can say HPO is performing better, but in some cases definitely HPO will be equal to the other techniques also, but not poor. Similar thing is also standard deviation and error. Error also I have gone through that. Means if we will operate the same algorithm for same task for 50 times, then what will be the average performance and the standard deviation of that problem, final output. So on that basis, I have also made this table, and again you will see this HPO is performing better or sometimes equal to the Gray Wolf population technique. For example, here in function 18, you can see all algorithms are not all Gray Wolf as well as the PSO and DE also, sorry, and all are able to give the good average result. So HPO is giving overall better result, but we cannot say that for each function HPO is not giving the best result, but overall it is best. Similarly, average error, I find the average error for all the functions, and then accordingly I decide. Similarly, the convergence curve I have shown. Convergence curve for all 23 functions, what 23 functions I have considered for testing. So in this 23 functions, you can see, so almost in each functions, HPO is performing better because red one is the HPO, but in few functions, HPO is very similar, very close to the other techniques. For example, function 16, all are converging on very on similar time or on a similar fashion, and like that. So HPO is overall performance of HPO is better here. Similarly, average function evaluation means here we decide what is the average number of iterations required to complete the task. And here during this average iteration decisions, I have evaluated each function 50 times for each algorithm. So on that basis, you can see the green one is the HPO, and HPO is performing better with respect to the other. But again, my conclusion is here for not on the all functions, but other functions it is better, but few functions it is very similar to the other one. For example, here function 19, Gray Wolf as well as HPO both are taking almost same number of iteration to conclude the results like this. So on that basis, we can say HPO have the good exploitation ability, local minima, and finally the promising of the solutions. We can say HPO is good. Also, I've shown the flow chart, but this is not important here. Directly, I'm coming on the target. Now I can use the HPO for solar panel maximum power point tracking. So for that purpose, this circuit I have used. Which here in this circuit, this battery is the part of the electric vehicle, means inside the vehicle, this battery will be here, and on that panel, the climate will change with the same speed. What speed I told means 1 second. In 1 second, again one after the one. In 1 second, the characteristic will change. And here, by using the boost converter, my task is to operate the solar panel on the peak like that. This is the key target here. So this is a simulation model. This is not important. Here during the testing, I have considered the 5 type of patterns. all 5 patterns I have shown here, and each patterns you can see the star one. This star is the global maximum power point, and the target is tracking of this point, and the rest other circle one is the LMP. So how this algorithm is performing, that I will show here. Similarly, this is the simulation result of my HPO algorithm, and so in this simulation result you can see that all 5 patterns I have considered here, and overall tracking time means average searching time of this algorithm is 0.48 seconds. Means that in 48% time this algorithm is investing for searching, rest 52% time this algorithm operates on the full extent. But this is a simulation result. Again, I will show the experimental results. That experimental result will be little bit higher than this, but that will also good. This is the algorithm parameter selections. Suppose algorithm parameter selection is wrong, then how the algorithm will behave. So here the 3 type of algorithm parameter selections I have considered: good, poor, and best. Then how the algorithm is performing means that, because here one algorithm parameter is omega, and means that if you are not able to tune your omega properly, then what will happen? In worst condition also, you can see here in all 3 curve, in overall tracking time is 0.6, means that in worst condition also this HPO will give the better result with respect to the state of the art techniques. For example, floor population has taken 0.85 seconds, but it is here average time is 0.6. For what? For worst or poor algorithm parameter selection on that situation. In best situation, this is 0.48 seconds, means far better. Similarly, the searching behaviors is like that. This is the very normal behaviors. Means they start from the any locations, anywhere, but finally all will converge on the peak. This is the thing. Also, I have shown the animation of that. During the animations, how all the particles converges. So in this curve, you can see the target is this dark red side, and these are the initial population's location during the iteration 1, and then iteration changing. So see, this is iteration 2, iteration 3, iteration 4, similarly iteration 5, iteration 6, and then iteration 7 and iteration 8. You can see during the iteration 8, all are almost on the peak, means all are close to the global. So this is the animational behavior of the whole algorithm. The same system, same circuit I have used for the experiment, also on the experimental setup, and this is experimental result. In this experimental results, you can see the tracking time. What I got here, tracking time for all the 5 type of patterns, what figures I have shown. On that, the average tracking time is 0.51 seconds, means 51% time for the searching, rest 49% time for the overall, we can say the full strength performance or the final populations, or like that. Here also you can see the efficiency. What are the PV characteristics I have considered on here on the experimental side? You can see this red one is the characteristics, PV characteristics, shading characteristics. This shading characteristics is 99.98 is the efficiency, means the global peak tracking is 99.98% closer to the true peak. Similarly, 99.97 and 99.99%. This is the overall efficiency of the MPPT. This is MPPT efficiency. This is not the panel efficiency. Panel efficiency is something else. MPPT efficiency is something else. MPPT efficiency means how much power we are capable to extract from the panel, extract from the available power on the panel. We know that power will be 20% of the actual energy, but how much efficiently we are extracting that 20%, this is the MPPT efficiency. And this is 99.98, 99.97, and 99.99. So this you can see this is the red one is the experimental characteristics. Here I have used the solar simulator so that we can see the efficiency and performance according to the time. And also the overall average tracking time is 0.51 seconds. Similarly, suppose no shading will be there, then how the system will perform. Maybe in some certain cases, no shading, then how the system will work. Then definitely the system will work also there. And then these are the 5 conditions I have considered. Definitely here, no multiple peaks, here single peak will be, and then tracking time is 0.34 seconds on simulation. Similarly, on the experimental, you will see 0.37 seconds without shading condition also. You can also see the experimental characteristics, and efficiency is 99.99%. like that. Similarly, I have compared the final result with the existing techniques. For example, PSO, ant colony, HPO, and FPO. From this, you can conclude that PSO is totally worst. So PSO is not able to track in within a 4 second. Here I see the gap. I have taken the 4 second, 0 to 4. So you can see here. Though I have not considered here PSO. See the ant colony. Ant colony able to track, but it's taking the 3.12 second. Flower population 0.77, and the HPO is taking 0.48 second. On simulation, this is a simulated performance. And comparatively, you can see how it is efficient. Similarly, on the experimental side also, 3.42, and here 0.83 and 0.51. You can see here this 0.83 is not due to me. The same when you will see the existing literature, also you will see their author has committed 0.85 second on experimental result. In my case, it is taken 0.83 second in flower populations. And now I think now you can understand of why this time, this small time change is very important, because in each second the situation will change. Each second the pattern is changing. So if this time have slight changes, so it can give a huge amount of power difference with respect to the existing solutions. Similarly, all the techniques I considered also shown the efficiency here. Here also you can see the HPU have the far better efficiency with respect to the others. Finally, the comparative results in the convergence curve. Here you can see the HPO means red one is converging far better with respect to the other techniques, and on simulation as well as the experimentation, the HPO is performing far better. Without shading condition, 3.7 is the time, and partial shading condition, this is 0.51 second. Means this overall performance you can conclude. Similarly, that algorithm what I used here, that also tested on the standard, because we know that in partial shading conditions, not in partial shading condition, for the solar, whatever techniques or controls we are making, we cannot use for the industrial purpose directly. First of all, we have to test on the standard. That standard is European standard EN 50530. So on that basis, they have given, in this standard, they have given two rules. The rule one is European efficiency calculation and Californian efficiency calculations. This is the formula for that. And similarly, for the dynamic efficiency calculations, also they have given two type of pattern variations, means solar radiation pattern, means low to medium and medium to high. Two type of pattern they have given, and I have tested on both. You can see here in the simulation results, the first one, the upper side, this solar radiation variation has shown here, and this is according to the condition, European condition EN 5053. You can see here, and this is long simulation. So you can see that this is the results, the power, voltage, current, and dynamic and duty cycle. So on that basis, also I've tested on the experimental setup. So experimental results also I've shown. Definitely I cannot show the whole results, because the whole simulation is 3000 second long. Result is that, means around 5 hours. So I have not shown the whole result, but finally we can see the efficiency, overall efficiency. European efficiency 99.981, California 99.77, and 99.49% efficiency I have achieved according to European efficiency. And according to this European standard EN 5053, only those algorithms we can use for industrial purpose which efficiency is more than 99%. If any algorithm have efficiency is lesser than 99%, we cannot go for industrial use according to this standard. So we can say this is able to perform on the experiment industrial level. So finally, I can conclude that HPO is far better with respect to the other technique which we can use for fast varying solar irradiation or fast varying partial shading condition. So through this, I can conclude my presentation today. But also I have shortlisted few problems where you can participate, and those are still untouched, or you can think about that. So that will also I will explain here. So few minutes I will take. The first upcoming area where you can participate or we can contribute, because I have used here soft computing based global maximum power point tracking algorithm, and on that basis I have shown here without shading condition time taking is 0.37 and partial shading condition 0.51 second. But other one is that without soft computing, means the classical mathematics based or deterministic optimization technique, just like P&O, INC, those are the deterministic optimization technique. That is also one solution for the maximum power point tracking. But that type of solution is not applicable for global maximum power point. That will not work in partial shading condition. But without shading condition, that algorithm will work, and the tracking time of without shading condition, those algorithm is 0.22 second. But if you will use the soft computing without shading condition, the time is 0.37 second. But the question is how your processor, how your algorithm will decide which type of pattern is on the panel. Means panel have certain shadow or without shadow condition, and how you will determine these things, how you will decide these things, and accordingly you will switch your algorithm on running condition, means online condition, from one algorithm to another algorithm. In shading condition, soft computing algorithms, without shading condition, deterministic algorithm, how you will decide. This is still untouched here. When I was presented this same thing in IIT Bhubaneswar, there one good solutions I found. The one student has given, he will use one camera over that. But that is not the final solutions. But definitely, you can think about that, how you can do like that. Another is vehicle-to-vehicle communication-based searching, means that in particular zone, particular type of shading is falling on the particular vehicles, and that vehicle have some certain soft computing-based algorithm. That algorithm is optimizing or searching and finding the final result and moving. So that algorithm or that vehicle can pass the final result to the other vehicles. So on that location, when that vehicle will come, so that vehicle will start searching from there. Means the initial searching positions will be according to the previous vehicle. Because we know that the sun is also rotating, the shadow will also change with time. But if some result will be from other one vehicle will pass the some result to the other vehicle, then searching will be much faster with respect to the other one. But definitely this is only possible when 5G will be in our market, means vehicle-to-vehicle communication will start, which is upcoming. So on that time, we can think about this also. The third one is you can think about the universal charger, because in the remote location, for example, this picture is in USA, in the remote area, government has just placed one solar panel on a pillar, that's it. No battery, no charger, nothing. Just two wire has given, and you have no idea about this panel. Just panel has placed on the pole, and how you will charge your vehicles. Definitely here required one charger. That charger have two capability. One, battery charge current, battery charging current optimization, or we can say keep the battery charging in a safe region, as well as maximum power point tracking to this panel. Both will perform by using your charger. So for that purpose, one portable universal charger. So this is also one good thing. Definitely few companies working on this. For example, Robert Bose is trying to make this charger, but still you can think about this. Thank you. I'm happy for the questions.
Thank you, Nishant sir, for your valuable talks. Sir, already I have some question from our audience.
Yes, sure.
Tapu sir has asked the questions, the battery replacement cost is considered or not. It is asked during your initial slides. So kindly, sir, elaborate these things, sir.
Here I have not, okay.
Tapu sir?
Yes, I can understand what the questions you have put.
No, I'm looking for the person who put the questions. Tapu sir, are you there? Sir? Tapas Nandi sir? I think due to the network problem, he is not connected right now.
Okay, no problem. But I can say here, no, here battery replacement cost and the cost of the whole body of the vehicle had not considered, not only in electrical as well as also in the petrol side also. The engine cost, vehicle cost, and the other cost had not considered. Only the mileage of the vehicle and the price of the fuel has considered during these calculations. Means other cost, means the body cost, vehicle cost, and all the other things are not considered. Not on the mechanical side as well as electrical side, not considered here.
Okay, sir. Thank you, sir. I will convey your answer to
Yeah, may I
sir.
please ask one or two queries? May I please ask one or two queries to Dr. Nishant?
Sorry.
Hello.
Hello.
Yes.
May I please ask you one or two questions? Dr. Nishant, are you getting my voice?
Your voice is little bit hazy, so I don't know.
It is not clear? Okay.
Yeah.
I'd like to know that actually you started your deliberation on electric vehicle charging schemes. Okay.
Yes, sir.
And there has been a lot of numerical modeling and all these things you did it. What exactly you want to tell? Actually, have you considered any research actually done by Central Electrochemical Research Institute, Karaikuri? They have the practical expertise on battery, and they have actually developed a particular battery whose life will be very long, actually long life and very low cost as well. Karaikuri. Okay. Have you considered any work done by them? Have you consulted any scientists of
No.
Central Electrochemical Research Institute, Karaikuri?
No. Currently, I have not considered these things, as well as also in the calculations. Also, I have not considered the charges and price and all the things in the calculations. Also, not considered about the battery. Only control side I have worked here, but definitely I also agree with that. So many new battery has came in market, and for example, plasma based battery is also coming in market, and new
Yes.
type of batteries are coming with a huge power density also and fast charging also. So many things are coming up in market, but definitely in these calculations or doing this control battery side, what are the constraints are there, that has not considered here. Only considered on the converter side, means that how the converter will operate fastly and according to the condition.
Actually, my submission was different. My submission was that there is a specific laboratory of CSIR,
Yes.
it is Central Electrochemical Research Institute, which is doing independently this type of job only. So they have very valued experienced scientists also. They are doing but they are actually connected with whole world as well. They are competing in the world market. So because you are doing some sort of theoretical work and all these things, it must be validated by the practical values or by the practical results actually. And if you like to do this one, you must consult your director or some of the scientists who are assigned to do job. You can note down the name of the institute. It is Central Electrochemical Research Institute. They are basically doing this particular job.
Yes, sir. Sure, sir. Sure, I will try to. Yes,
This
sir.
is my submission to you because you are a very young fellow. You have a lot of years to go ahead. So if you do certain research, whatever be the research, theoretical research you are doing or all this, that must be practically validated. And if you lack the practical validation of your model, then you must consult somebody, those who are actually working in the field in this area.
Yes,
So
sir.
this is the expert laboratory in our country as well. So I will ask request to consult any of the scientists of Central Electrochemical Research Laboratory at Karaikuri. Okay? Thank
Yes,
you.
sir. Sure, sir. Thank you, sir. Thank you, sir. Thank you for the valuable suggestions. Definitely, I will try to consider. Okay, sir.
Yeah, Nishant sir, I have another questions from our another faculty member from
Yeah.
Professor Dola Sina. She asks about the challenging aspect of the battery charging. So he's concerned about the time taken by a battery charging. So if you kindly elaborate this portion, then it will be very much helpful for us.
Yeah, if, here definitely the two thing is here. Battery charging is also a very challenging task here, because and also battery have two or three type of charging behavior. So one is the fast charge and slow charge. Another is the parallel charge or speed charging. What are those things? When you are charging your battery slowly, then definitely battery charge is not battery charge. Battery will definitely charge slowly, but battery life will increase. Slowly charge means you are charging your all cells in series manner, one by one you are charging. So that what happens when you are charging one cell and then another cell and then another cell. So in this situation, in this manner, the battery cell resistance produces less heat with respect to the parallel charges. So it takes time much more, but it life increases, battery life increases. But the question is, when you will charge faster, means the all cell will charge parallelly. So more amount of heat will produce inside the battery. So it will charge faster, but then it will impact directly on the life of the battery. So here we can think about the two way. We cannot say so always I will charge in a slow manner, because in the daytime when you are running in market, that time on a charging station or charging platform, you will charge slowly. It will take 1 hour. This is not also not feasible. Means you will stop your vehicle on a one location. You will charging 1 hour, 2 hour. That is also not a good solution. Another one is we cannot say all time you charge faster. So we can think like that. We can make a arrangement like that. Both means in night time when you are going home and you are charging your vehicle, then you have enough time, means whole night you can charge your vehicle, so you can charge in a slow manner. But in a daytime, the same battery, same infrastructure can be used for the fast charger also. So that type of connections and arrangements we can think in that way. Few companies are also working on that in my knowledge. For example, one is Toyota. Has also built this arrangement, but they are trying to make these things in wireless charger. In wireless charger, they are trying to arrange this, but they are still facing problem. And currently, they have launched one project also in this area. So how in wireless connections make these things? So you can think about this. Any other? Thank you.
Thank you, sir. Participate, you can put your questions, unmute yourself and kindly put your questions. If you face any difficulties in your net connection, then you can directly put the question in my WhatsApp number or in the chat box. Please, sir, or please, madam. Any question from the participant?
Hello.
Yes, sir.
Hello.
Sir, I think.
Hello.
Yeah. Please, sir, carry on.
I have one question. What is the difference between a global maximum power location?
Yeah. Global and local maximum power. Right. Just answer. In this figure. Not this figure. Go on here. See in this figure. Suppose this curve have the multiple peaks. So many peaks are there. Means so many multiple. For example, this one, the first figure, pattern 1. You can see the multiple peaks are there. So which one is the highest one? So that one will be the global one. And rest all the peaks, all the valley, the peak of that valley is local. So this is just nomenclature, nothing else. Means the highest peak is the global, and rest other one is the local.
One more question.
Yes,
You
sure.
say that one vehicle can pass the information which is ahead,
Yes.
which is behind it. Huh? So you are saying about the shadow pattern of the building for construction, etc. No?
Yeah, setting
Buildings due to building.
with location and the siding pattern information. Yeah, siding pattern information with location. The one vehicle will pass to the other vehicle, so that vehicle will come on that area. So according to the location, that vehicle may use that, but definitely that result will not work for that vehicle, because with time the shadow area will also change, but the change will be with the speed of sun, which is slower. So that will helpful for other vehicles. Yeah.
My question is, it is the shadow pattern due to the building construction. So for a particular city, which is at particular longitude and latitude,
Right.
is it possible to build a shadow pattern over the year, and
No,
we pass this information to the GPS system to a vehicle?
But again, this is one way. But this is again the so many things will be come here. you will use the GPS for that, and then what is the exact position of the vehicle on the road, and then what is the longitude, what is the positions, and that is how much that is matching and all. But here, what I suggested for pass, you can think about that what you are telling. So you will use one GPS system to track the shading pattern on a vehicle and according to the vehicle locations of the road, and then you can go for that. This is one way of area you can think about that. But what I have suggested, in that way, we are not going to say the area or pattern of shadow. In these situations, we will only pass the optimal result of the search. Means that suppose one car is running and car has optimized that shadow in that location or that area, then that optimal result means what is the voltage and what is the power for that shadow, which location will pass to the other, so that other vehicle will use that voltage as a initial population power can use, like that.
Thank you, sir. Any other questions from the participant? Yes, sir. Sink, sir, please.
No, thank
Any
you.
other question from? Okay, sir. Any other question from the other participant? Hello.
Hello, sir.
No, I think we don't have other questions for today. Thank you, Nishant sir, for your valuable talk. Yes, or I think HOD sir. Sir, any question? Okay.
No, no.
Thank you, Nishant sir, for your valuable. Yeah.
No, thanks, sir.
Okay. Okay, sir. Okay. So thank you, Nishant sir, for your valuable speech, and it is a new dimensions we have introduced, how to use the nature energy to reconstruct our future with a clean environment and the clean nature. And it is just a pathway, and we are very much happy to have a new researcher, young researcher like you, who give us path to follow that thing. Thank you for your all the presentations and the valuable talks, and thank you all the participants.
Thank you.
And thank you, Nishant sir, again to give your valuable time. Thank you, sir. And the feedback process and the attendance process will be given in the chat box. It is a humble request all the participants not to share to anything, and kindly give the feedback within the 10 p.m. by today. And kindly don't share this link to the others. It is a humble request. And I have another, due to some difficulties, our next speaker, that is a Professor Dr. Sumit Kumar Chattopadhyay, IIT Delhi, due to some unavoidable circumstances, he cannot join right now. He is facing some huge problem. So we are in touch with the sir. So whenever he is convenient, then definitely we arrange another date to give his eminent talks regarding his topic, and we definitely give a prior information to all our participants. So we are going to conclude our session at here, and definitely we meet tomorrow 7 p.m. with another eminent speaker, Professor Dr. Amitabh Chatterjee, Jadavpur University, and the topic is a learning strategies for the human-robot collaborations. And meanwhile,
Okay, thank you, Nishant. Thank you, Nishant. On behalf of Dr. V.C. Engineering College Authority, I invite you to visit our college when this pandemic is over, and
Yes, sir.
speak to our students and your faculty and share your knowledge and experience physically. Okay, it's a standing invitation from our
Thank
college
you.
authority. Thank you.
Thank you.
It has been an excellent topic, excellent talk.
Thank you, sir.
finally, I would like to thank our eminent speaker today, our director sir, our registrar ma'am, our head of the R&D cell, our HOD sir, and our coordinator, and all the participants. Thank you for this, and hope to see you tomorrow at scheduled time. Thank you, sir, everyone. I'm concluding the session. Thank you. Dr. Ali Hassan, sir. Is it audible? Dr. Ali Hassan, sir.
মিস করলো তো মনে হলো।
Yeah, after a long
আচ্ছা।
layoff, virtually we have met again. Nice to have you, sir.
Thank you, sir. Thank you.
And it is again a virtual visit to our college. Thank you, sir.
Okay.